This is Mrs. Davis. This is AP Calculus Lesson 8.2, Connecting Position, Velocity, and Acceleration with Integrals. And we are on video 3, and we're looking at a few more examples of using integration with particle motion. So let's look at example 3, a particle's velocity. So they're giving you the velocity function, and they're saying x of t represents the position of the particle along the x-axis. Find the position of the particle after 3 seconds if x of 0 is 5. So now this, guys, is position. This is asking for position, not displacement or distance traveled. So that means we have to take in consideration this initial value. Just like in accumulation, this would be, what it started at, what it had started before it started accumulating. So this is the same idea, only it's specific to be velocity and acceleration. So that means that we would say that position is equal to x of 0 plus the integral from 0 to, and we want it after 3 seconds, 0 to 3 of v of t dt. Now this is a non-calculator question, so we would say that's equal to 5 plus 0 to 3 of 4t cubed minus 6t squared plus 1 dt. Okay, let's move up here. If I take the antiderivative, I get 5 plus 4t cubed over 4, so t to the 4th minus, and that would be 2t cubed plus x from 0 to 3. So that is 5 plus, and then we have 81 minus 27 times 2 is 54 plus 3. Now, it should be, minus 0, this whole thing with 0 in it, but that would just be 0, right? Okay, so watch out, though, if it was trig or something, you got to watch out that it doesn't all go away. All right, so that would be 5 plus 30, looks like 30, and you get 35. So the position is 35. Now we should say from, it's positive, so from to the right of starting position. Okay. Find the position after 2 seconds if x of 1 is negative 2. So now they're giving you another starting point. So we do the same thing. The position this time would be x of 1 plus 1 to 2 of v of t dt. So that's equal to negative 2 plus, what do we have for a function? Well, you know what? We already took the antiderivative, so we can just start right in there with t to the 4th minus 2t cubed plus, and all those probably should have been, this should have been a t, right? Sorry, plus t from 1 to 2. And so that's negative 2 plus 16 minus 16 plus 2, and then minus, I have 1 minus 2 plus 1, so you get negative 2 plus 2 minus 0, and so you get negative 2 plus 2, so it's 0, so it is at 0. Okay, let's look at this is something from College Board. And I got it several years ago. I don't know if they still use it, but I thought it was worth looking at. I think it's worth looking at. They call this the NUT strategy to interpret motion integrals. And so, see, NUT is noun, units, and time, okay? And just kind of understanding what each thing is for a certain integral. So I can look right here and see this is going to be a position because it starts with initial value. So we would say that the noun is position. So let's go through all the nouns. Let's look at the second one. They tell us this is the change in the position of the particle from t equals 1 to t equals 4, right? This one looks like the average. Okay, this is an average of absolute value of velocity. So this looks like it's average speed. This one looks like it's position again from 4 to 2. Well, from they give you initial position and they want it to be 2 seconds after. So you have to use the initial position and then 4 to 2. And then this one looks like it's the total distance traveled, the absolute value of velocity, right? Between those times. And then this one is going to be, and look, it's the average, but it's the average acceleration. Remember, it's the average of what's the average. So this is the average acceleration of the particle. So let's talk about units. If I had position, and I want the position, and let's see, let's say it would be feet in seconds. So this would be in feet, and at t equals 4 seconds. The change in position would be in feet also. This is feet from the origin. And average speed is in feet per second, okay, and this one is in feet from the origin. Again, the position. Total distance traveled would be in feet. And the average acceleration would be in feet per second squared, because it's acceleration. The average acceleration is acceleration. And so this, let's see, this was from, I had written it over here, but they had a little space for it here. From t equals 1 to t equals 4 seconds. And this one is in from t equals 1 to t equals 4 seconds. Okay, this one would be position at t equals 2. Okay, they said, you know, what's the position at t equals 2 seconds? They want an exact position, so it's not an interval. From 1 to 4 is there, and then the average acceleration would be, again, from t equals 1 to t equals 4 seconds. So again, just kind of an overview of how to distinguish between each thing that could be asked for. So now you try. This is a non-calculator run. So shut off the video, give this a go, and then come back and see if you got the wrong thing. I will tell you that the math is a little bit yucky. It is a non-calculator one, so it gives you 3 halves there. So just give it a go. All right. So if you're back, what is the total distance traveled by the particle during the first 4 seconds? All right, so now, I don't know if you were able to figure this out, but if you're doing this by hand, it's positive here and it's negative there. Now the calculator takes care of the positive and the negative side if you just give it the interval. It knows what's positive and negative. But if you're doing it by hand, you're going to have to do it piecewise. And you're going to have to take the positive piece, and instead of adding the 2 pieces together, you're going to have to subtract the negative piece. Okay, so the total distance, let's write the formula though, so we get a point for that. The total distance is equal to, let's see, from first 4 seconds, so 0 to 4, of the absolute value of v of t dt. So that'll probably get you a point for writing that down. So now we have to split this up. This is the same thing as from 0 to 2 of v of t dt. And the only, how did I know where? Look, if you have to do it by hand, you're going to have to graph this. You're going to have to graph negative 1.5 t plus 3 and see where it starts to go negative. And it started to go negative at 2. So you're going to have a little sketch and try to figure it out. When does it cross the x-axis? Okay, so again, you don't have to worry about that if it's a calculator because it takes care of it. Now this would be minus, because I'm subtracting out the area underneath the curve. And so that would be 2 to 4 v of t dt. So that's how you remove the absolute value when you're doing it by hand. Okay, and so now you have to do the math. Now, this could also be written as the absolute value out here of 0 to 2 vt dt plus the absolute value of 2 to 4 v of t dt. Because, you know, this is like subtract this. If you look at what you have, whichever side is negative, you're going to be making it positive. And if you're going to get the total distance traveled, they have to be added together. So I kind of might have just explained that wrong, because it's wanting the total distance, so it wants this and this. If we add them together, if we just do the interval, it will subtract off this instead of adding it. So that's why we put a negative. It's really going to be like a negative negative to make it positive. So really, this one kind of makes more sense to write it like that, but it's the same thing. Okay, and I do usually do it like that. When I have an absolute value, I subtract off the negative part, which really is adding it. So you still have to find the breakpoint, though. No matter which way you go, you still would have to find that too. It started to change, because you have to have two pieces. Okay, so let's just do the math for this. This would be negative 3t squared over, let's see, what do we have for our function? Oh yeah, negative 1/2 t, so negative 3/4 t squared plus 3t from 0 to 2 minus negative 3t squared, same thing, over 4 plus 3t from 2 to 4. And so you get, let's see, negative 12/4 plus 6, which is 3, minus, this is negative 12 plus 12 minus 3. So you get negative 3. So 3 minus negative 3 is 6. Okay, so that would be the right answer. Now you could do it the same way here, and you would still get 6. All right, so that's lesson 8-2.